Welcome to FeatInsight, an online ML feature management system on 4Paradigm Sage Studio platform. Feature management lies at the heart of modern machine learning development, covering various tasks. In a real business scenario, about 95% of effort is spent on feature management. However, designing a feature management system poses several key challenges. First, hundreds or even thousands of features may cause high dimensionality. Second, data contributing to final features often exhibits complex relationships, making it difficult to analyze. Moreover, aligning features across different execution engines need consistency checks before deployment. Third, frequent updates and redeployments are required to accommodate shifting scenarios. To address these challenges, we design an online ML feature management system, FeatInsight. First, to simplify the process of constructing skull statements, we provide a visual feature design tool. Second, in FeatInsight, we utilize feature views to collectively group and manage features with similar usage patterns. We support feature lineage management, making it easier to trace the evolution of feature definitions. Third, FeatInsight employs execution engines optimized for ML scenarios. For offline data, it enhances resource utilization by parallelizing window operations on the same tables, and mitigates data skew by dynamically reassigning window data. For online data, we apply pre-aggregation to handle long time intervals. For data import and compact management, FeatInsight employs a compact encoding format that reduces memory usage by combining fixed, size, and variable size data structures. After logging in the system, we first create a database to organize our data. Now we create some data table using different methods. We can also use SQL to define the schema. For real-time feature serving, we need to associate this table with an OpenMLB online table. OpenMLB online tables store recent data in memory for low latency access. The TTL setting ensures that only the last 30 days of transaction data are kept in memory. Now we import user data from CSV file or via SQL. Notice the import target option. We can choose to import to offline, online table only, or both. You can see the import progress in real time, including status updates and logs. After that, users can view table schemas, check related feature views and services, preview actual data, and manage OpenMLDB online table configurations. Now we create some feature views, which are reusable SQL definitions that compute ML features. FeatInsight's Visual SQL tool allows users to build complex SQL queries visually by connecting nodes, generating automatically the with clause with SQL statement. This is especially helpful when building complex feature pipelines. After creating feature views, users can see the SQL definition, feature names, data types, descriptions, and feature lineage, knowing which table the feature comes and which deployment it is in. In the offline scene, users generate training datasets for machine learning models. The system supports various export formats and Spark configurations for large-scale data processing. Users can monitor the progress in real time with detailed logs. Now we deploy features as online services for real-time inference. The feature service will automatically use the OpenMLDB online tables we configured earlier, assessing the latest data stored in memory. Once online, the service starts accepting requests and you can see real-time metrics like queries per second and average latency. Let's test the feature service with a real request in form or JSON mode. The service returns computed features in real time. JSON mode allows batch requests, which is essential where we need to compute features for multiple users simultaneously. The format is compatible with OpenMLDB API server. Clicking the online-offline consistency validation button, we can compare feature values and highlight any discrepancies, so that identify potential data drift. The real-time dashboard provides system-wide monitoring capabilities, including average latency, transaction throughput, and system resource usage. In SQL Lab, users can test SQL statements, explore data, and validate feature computations before deploying them as feature views or services. Pre-compute features allow users to store frequently used features in online tables for faster access. Users can preview features and query them using indexes, similar to Redis like key value lookups. FeatInsight also supports automated feature selection and augmentation, employing beam search and successive mini-batch gradient descent to generate and evaluate high-order cross features.